Okay, I'm going to go over the formative. So you can see right here, we're covering linear, exponential, and quadratic functions. So obviously we're not really too sure which one's which, but we're going to cover all three types. So it starts off with a question, examine each situation, and determine if the situation is linear, quadratic, or exponential. So linear is y equals mx plus b. Quadratic is y equals ax squared plus bx plus c. And exponential is y equals a times b to the power of x. So for each situation, you're going to create a function, a table, and a graph. All right, so let's look for key vocab. Starts at a temperature of 360. Okay, so what am I going to do? I'm going to go into here. So starting would be your y-intercept. So at 0 hours, it's at 360 degrees. And then it says it cools by 80 degrees each hour. Okay, so after 1 hour, it's going to go down by 80 degrees. So 360 minus 80 gives us 280. Okay, because minus 80. Okay, and then after 2 hours, when I take away 80 again, that's going to be 200. And after 3 hours, it's going to be 120. Okay, so that's our table. So now it says write an equation. So I can see that this is decreasing by 80 each time, which means my slope is negative 80 and my starting value is 360. So the y-intercept is 360. So because it's a constant rate of decrease, when you see those constant patterns, that means it's going to be linear. Okay, so that's your b value, and then this would be your m value. Okay, so you could write in here y equals negative 80x and then plus 360. Now, if you hit a wall, or if you want to double check your work, you're like, oh, I don't know if I got the right one, you could always input it into Desmos. So you go to table, 0 hours is 360. Oop. Darn it. Oop. 360. There we go. All right, and then after 1 hour, it's going to be 280. Oh my goodness. Bear with me. After 2 hours, it's going to be 200. And then after 3 hours, it's going to be 120. So based off this information, punch this in this way, we can see that this is also, adjust this around. We can see this is a straight line. So without anything else, I could see that's a straight line. So I know that's also going to be linear because of that. Okay, so linear regression, negative 80x plus 360, that matches what I already have. All right, so the question is, does it represent linear, quadratic, or exponential? So like we mentioned before, this does represent a linear relationship. All right, graph the function. So when it's on formative, you're going to have to select, there should be a drop-down menu to, I'm not on formative right now, but there should be a drop-down menu to select. I believe you only need 2 points. Oh boy, this is not the graph that was, I thought it was going to print. But you just need 2 points. So I would just select 2 of your points from here and then make sure you select linear, okay? So the prediction, without regard to room temperature, if the liquid was allowed to continue to cool, what would the temperature be after 4.5 hours? So hours would be your x value. Temperature would be your y value. So you could plug it in. So y equals negative 80 times 4.5 plus 360. Okay. And if you put negative 80 times 4.5 in your calculator, that would be negative 360. Okay. Oh, I wrote that wrong, sorry. Plus 360. Okay, so it's predicting that it's going to be 0 degrees, which obviously that wouldn't work, but it's just based off the trends, right? Okay, so a hot liquid's being observed after it cools. So this is a whole nother situation. So it begins at 360. So same thing at 0 hours, it's 360 degrees. And after 2 more hours, the temperature is 352. So 2 hours, 352. And then after 4 more hours, it's 328. And then after 6 hours, it is 288. Okay, so I would say start a new table. This is going to help us know kind of whether or not it's going to be quadratic or if it's going to be quadratic or exponential. So we have 0, 2, 4, 6, and then we have 360, 352, 328, 288. Okay, so let's take a look. So we can kind of see it looks a little more of a parabola shape, I would say, than exponential, but you can always double check. So if I do linear, you can see it's not quite on the line. If I chose quadratic, you can kind of see how it follows along with the arch. Also, your R value right here, I'll highlight it. I don't know if you can kind of see it highlighted, but right there where I'm trying to highlight at the bottom, your R squared value is 1, so that means it is perfectly on there. We can also just try exponential. It does look close, but you can kind of see it doesn't really align really well. So the best one is definitely going to be quadratic. So that's going to be negative 2x squared plus 0x plus 360. Oh, you can see that this point right here is supposed to be on the next page, but it's okay. Okay, so y equals negative 2x squared plus 0x plus 360. This can simplify. You don't really need the 0x, so it's just y equals negative 2x squared plus 360. This would be the most simplified. Okay? All right, and then like we said, we knew from our regression, it does represent a quadratic equation. Same thing with this graph. You would just do the points and then make sure you do on the drop down, you select quadratic. And then what would the temperature be after 9 hours? So you could just, well, there's several ways. You could just replace your x. How many hours did it say? 9? Replace your x with 9. Oop. Zero times 9 is 0, so that would be 198 degrees. Okay. All right, last one. So starts at 360. Starts at 360. After 1 hour, it's 180. Change the colors. 2 hours, 90. And we can see this is actually going by half. So already I could tell you it's an exponential function. And after that was not a color change. 3 hours. Oh, like that. Whatever. It's 45. Okay, so like I said, I could already tell it's going to be exponential based on the pattern of going by half. But 0, 360, 1 hour is... Oh, why do I keep making mistakes? 1 hour is 180. 2 hours is 90. 3 hours is 45. So starting at 0 hours, starting is 360. After 1 hour, one hour is 180. 2 hours is 90. 3 hours is 45. So you can see the green dots right here. If you take away the other ones. Okay, so if you take away the other ones, you can see the green dots right there. Those, you can definitely see it's an exponential function. But, so definitely not linear. Definitely not quadratic. It does look like it's close, but you can see there's like a gap between the points. Your R value is pretty strong, but it's not what you want it to be. But you can see with exponential, your R value is, your R squared value is 1. Also gives us our equation right here, 360 times 1/2 the power of x. So, y equals 360, 0.5. power of x. You could also recognize you're going down by half every time. So you could also put 1/2 x. And I'm going to put or. Okay, so 1 or the other is fine. Okay. One's in decimal form, one's in fraction form. And then, because it doesn't specify to write in decimals or fractions. Does it represent linear, exponential, quadratic? This one is exponential. We already talked about the graph, so you click 2 points on there. It'll graph the rest. And then what would it be after 4 hours? So I just replaced my x value here with 4. And that'd be 22.5 degrees. Oops. And that's it for that formative. Okay, so I'm adding on to the last video to go over the graphing. So this is part 1. So this is what your screen would look like. So just bear in mind, like I said, there is the drop-down menu. So you should know at this point what type of equation you have. You should see something like this. We're kind of limited on how we can adjust the graphs for you guys. But if you go back to your original graph, you can see it says 0, 360. So what you need to do is just grab your mouse and bring it down, okay? So bring it down. You can see where the Y is right there. You can see which one's Y. See on the right side, there's an X. And then you just click. Oh, see, I got the wrong one. Just try until you get the point you want. And then the next point after that was 1 to 80. So I'm just going to do my best to try to click it and see, like I said, I got that wrong, so try it again. If you need to zoom in a little bit, you can. So this one's just kind of playing around until you finally get it, which I did not. So you can kind of see I'm having difficulties, so don't be stressed out if you're having some troubles. As long as you have 2 points, it'll be fine. So let me show you what it looks like with the other ones. So this one right here, so starts at 360. So I'm going to scroll up to 360. I'm just pinching and just bringing it higher numbers, and then I could zoom in too. So 0, 360. Then it says after 2 hours, it's 252. So I'm going to scroll down closer to 250, and I'm just going to zoom in a little bit more. Oops, see, you just got to play around with it. No. No. There we go. Okay. So, and then this one's not linear. This one we said was quadratic. So you can see that's the next, you can see how it changed that line to match it. And then the last one we know is exponential, so I'm going to change that to exponential. And the points for that one were somewhere 360 and then 180. So this is what it looks like to start with. I'm going to scroll up, just kind of push it down till I see 360. You might need to try it a few times. Make sure the point that you grab is the point that you're looking for, okay? And then it drops to 180. So I know my X value needs to be 1, my Y value needs to be 180. I just click it right there. And if you zoom out, you have a better idea of the graph as a whole, and actually graphs your asymptote for you right there as well.